Everyone, this is Shamaila Sekhi from Group 6, Project Group 6. Today we are here to discuss about the artificial intelligence topic, and that is training AI programs. We are 8 members here, so we're gonna introduce about this topic. So next slide, please. So here our content is introduction, then we will come to the main context, and then we will show a demo result, and from discussion we went through the conclusion. So next slide please, Mama. In the introduction part, I just want to introduce about the image recognition categorization. So image categorization has a wide range of applications and can be utilized in a variety of tasks. It aids in the classification of various land projects with various uses. To complete the project successfully, many types of packages and tasks are imported here. This project also shows how to split the data set in order to complete it successfully. Many areas used data are used for urban planning and high resolution photographs, and are also used to classify the impact of damages after natural catastrophes such as floods, tsunamis, and natural droughts. To classify land use taxonomies such as buildings, vegetation, and pavements, as well as many other identifications. The training data is derived from Google Photographs, which was used to select many images of the President of the United States for the train and test the data. With around 80% and 20%, the picture data is separated into train and test data to ensure that the result is successfully executed. The data set is kept in Google Colab. Next slide, please. So here in main context, we import numerous crucial libraries here. So including pandas, NumPy, TensorFlow, OS, Matplotlib, and many more, as well as glog. Importing pandas to import data sets, NumPy to do any mathematical calculations, TensorFlow to run the sequence, and Metaplot library for data visualization are all useful for quick numerical processing. TensorFlow has been imported. Sklearn has various sorts of machine learning tools for statistical modeling and deep learning. There is also a learning API, Keras, which is a deep learning API that is used for fast experience, and PIL, which can read images with Python. Can we go through the next slide, please? Okay, here the dataset is imported from Google Drive. The dataset is already uploaded in Google Drive, then it is imported to Google Colab. After importing the dataset, use Globe to read the dataset that is already imported. So Globe is used again to train and test the current dataset. At first, the dataset is trained, and then Globe is used again to test the dataset. Now, my other teammates will continue with the presentation.
Thank you, Shumalia. Here I will discuss about merge, train, and test data set. We have used this Google Colab, as this Google Colab is used for this data sets. So large number of data sets also it can run without less internet access also. In this, we have used text plus train command to merge all the data sets, merging the data set to keep it into a data files variables. Next slide, please. And here we have the split the data. Here the data set is split with a test size of 0.2, and train and test those data with axis 1. Image size of where we have taken the value to 260 is taken, so that will be executed. Next slide will be accompanied by my teammates.
Yeah, hi, I'm going to explain about train and test the data. Here we have used array is used for train the data, and pd.get dummy is used for data type, and np.unique int image is used for reshaper, and The next slide, please. So for the test data, like we have used np.array is used for test data where data type is np.uni nt8. Reshape is also done in this. The shape of bin image value is 36, 220 and 221. Adam optimization is used to replace the optimization algorithm in the deep learning method for stochastic gradient. Adam is combined with the best property of RMS properties and also ADA grad. This algorithm provide a better and optimized algorithm that can handle the gradients on any problem. Vandana, can you show the flowchart? Yeah, here the train and test data flowchart I'm going to explain. Here first we'll get the data and we'll split the data in two parts, like 80% will be a train data and 20% will be a test data. It can't be like every time it should be 80% as train data. It may be like 70 and 30. So whatever the train data will go for checking for the target. For checking the target, like we'll go for example, if there will give some inputs, then it should be like get some predicted outputs. Here we'll check for the observations. Then if there is no, then it is like unsupervised learning. If next it goes for evaluation the model, and then it checks for the numeric values or like classifications. Then if it has numeric values, then it goes for the regression. And again, we'll go, if it is other than numerical values, it goes for classification. And then after that, it goes for the training the model. Then after the training, then we'll go for testing the model using the both uh, classification data and regression and test data. Then also after the testing, then again it evaluates the model and which checks for the numeric and classification. Then once it done with testing, then test the model. Then it if it is correct, then we'll get like root RMS, which is nothing but root mean square error. If no, we will go for uh, confusion matrix. So the next slide will be explained by my teammates.
So this is the normal image processing, how the image processing will go on. And once we have started first collection of the data, and next is analyzing the data. And after analyzing data, it will go to split the data. And as my friend explained, one is the test and train the data. So if the data is not found, and it will go back, and it will collect the data, and every time it will loop on. If the data is positive, data is came on, then it will go to train the data. And once they train the data and test and evaluate it, it goes. And once it is tested and it is accurate, then it will go to model deployment. Otherwise, this data analyzing or the image data analyzing process will be go on. So this is the how image processing will be go on. And the next one. So here I have clearly explained then how the TensorFlow work in the image processing. And first we have to install the dependencies and model, which is explained in the which is available in the GitHub related to the TensorFlow. And after that, the collected dump we have to take, and we have to split the images into training and testing images. And so once we have created the TensorFlow record and both the train and test image, we have to maintain the folders and what are the test images and what are the train images. And once it is done, and downloading the pertained model and configuring the configuration files. And after that, it is goes to training and the custom image using the previous pertained model which we created. And after that, training the custom image yeah, using the pertained model. So once the training is completed, then we have to, once the testing and training testing is completed, then we will start the training. So this is the flow. And the created model, exporting the path using the checkpoints what we have saved before. And get frozen, this is the .pd files we will create once the training is completed. And make the detection using the newly created model. So this is the process of the TensorFlow. and my friend will continue next. Next.
Thank you, Sahas. Now I'll be explaining about the result. So in the result, we have shown here the data frame result and also the trained data. So in the data frame, we have a data frame that has been created due to the image classification project. So here, in addition, we have added three folders here. You can see on the screen the folder, file, and the label, and all we have collected all the images from the Google and stored in the Google Drive within these folders, and execute the whole task up uh, prominently. So in the above figure, we can see that of the train data, the X train that has been created and utilized successfully. And although the figure executes the train task successfully, the printout shows the display outputs of the task. So X train CSS are used to resize the X train in the image clarification. So yeah, now the next slide will be told by my friend Saitej.
Hi all. So in this slide, I have covered the resultant shapes of the X text values
Next,
and also the checking model summary. So the above image shows the X values of the result, and moreover, the print option which is used to print the utilized data successfully after the execution of the task completion. So the X train command was applied to show the test exercises and also the result in this program. And after this, the program results are also being visualized. So the output of the model summary is visualized in the corresponding images, and all the results of this model are shown after the execution of the code. And the output results are also shown as per this program. And in this project, total param and trainable param is visualized in this results. So the next slides will be covered by my teammates. Thank you. Next slide, please.
Yeah. Now we are moving on to discussion. In the project, several images are gathered from Google Images to make the data set. Here, 45 images are being taken to share and get the data through deep using Python. Google Drive is used to save the data file using it on Google Colab. Those images are divided into 80 and multi-function for sharing and getting the data. Google Colab is used to get and share the data and for image classification. The share and get data images are split into categorical form. The data set is made sequential for different corresponding tasks. All the results and whole program is shown as per the image classification with presidential data. Now moving on to conclusion. From the above project of image classification, it can be considered that all the images are taken from Google Images and implemented on Google Drive to use with Google Colab. In this project, the images are used in a sequential way to correspond to an image classification program. The dataset of vector is chosen to complete the whole project and implemented from Google Colab software. The outputs are discussed to understand the program of image classification. The data has been taken from Google Drive and it is implemented on Google Colab to take and check the data. The whole model values are taken to define the layer of key values and all the shapes of output corresponding to the project. In the end, it can be considered that with the above code, the presidential images can be classified. Now, Modena is going to give the code demo.
Hello. So I'll be showing the code demo. So this is the portion where we will be importing the libraries such as the pandas, numpys, and TensorFlows. And once we execute this, our libraries are imported. Yeah, so then we are going to mount our drive. So it says the drive is mounted, and then we are reading our files, test data and train data sets here using the Google Colab. And once then we are like training our data set, and then we are testing whether our data set is appended like in our folders. So as you can see in the drive, in my drive, I see in the data set, I see two different folders now where I have the test and the train data set. And then once that is done, we go ahead and combine our train and test data set and update it in the data files. And once that is done, I'm going to split our details, the file names, and then we are going to check whether they are train and test, and then creating that label and also like getting the folder names. Once that is done, I'm creating the data frame here to store those values in one particular data frame. So let me show you the top 10 details that are in our data set frame. So this is how our data frame has. So I'm just showing you the top 10 details from there. Now, as we go on to the data set splitting, so here, based on the image, like whatever data sets that we have, we are like splitting it into the test set and the data set, and we are giving the image size, we are limiting the image size to be 260, and then we're creating another data frame with the training set 2. Now, when we execute this code, it's like setting the like resizing the image and reshaping the image for the given numbers. And now, when I train the array, it says that our X train is train. So then we have another data frame where we're doing the second test. And here it says our second test is done. So as you can see, it says the test is done. And then when we are reshaping our image sizes, and our image size is reshaped to 36, 20, 20, 260, 261. Now we are also importing the TensorFlow libraries. And once that it's done, I'm going ahead and creating the model using the like, as you can see, we have the max pooling ones and convolutioning ones. And like this process is repeated multiple times, and then we are doing the flattening and then dropouts and dents. So we are creating a sequential model for our particular data set. And once that's done, I go ahead and compile that, and let's see what's the summary for our data set, like our model here. So this is our sequential model summary, as you can see that. And then what we're doing in the Adam optimization here, right here, is whatever the margin of error it is, we are like trying to optimize it using the Adams optimizer and putting down the value lower to that. So after this, we'll be able to get the accuracy. So that's it, guys.